Good evening, one and all, and welcome to Flat Earth UK Live. Joining me tonight is the host of The Morgile and co-host of Globebusters on YouTube. John, welcome to Flat Earth UK.
Hey, Nathan, how's it going?
Superb. I'm really pleased to have you on the show. On tonight's show, we will be asking, where is the curvature? Where is the proof of gravity? Why does the Coriolis effect make no sense? And looking at why aeroplanes prove we live on the flat Earth. John, can you start off the show by telling us, how did you find out the Earth is flat?
Sure, that's a great question, and I suppose it's something that we've all sort of known our whole lives. I can think of things that I sort of pondered about my entire life as a globe earther that just didn't really make a lot of sense, and we just sort of, apologize for these facts and just continue thinking it's a globe. And so ultimately, after years and years going on like that, I saw some links on the internet involving this flat Earth conspiracy, and I thought it was the stupidest thing I had ever heard. And I don't know, I guess it would be a few months later after that, I had a conversation with a friend who is not at all conspiratorial minded, at all. And so we have our disagreements, but he mentioned to me, well, you're not a flat earther, are you? And I was like, what? Like there's such a thing, right? And so that conversation ultimately led me to just click on a link one day that had to do with flat Earth, and it was Matt Boylan, Math Powerland, whatever his name is, however you want to call him,
Math Powerland.
Math Powerland. And I watched a bunch of his stuff and just started considering some of the things that he was saying, and made a lot of sense. It answered a lot of these questions that had been sort of lingering around in my mind. For example, the flight times from east to west, which we can get into, or for example, the constellations remaining fixed in their alignments throughout history, or, for example, there not being any difference from January 1 to January 1 year after year if we're actually going around in sort of a parabolic curve around the galactic center. And so, this flat stationary Earth model started making a lot of sense. And of course, I was sort of addicted to this thought, this idea. Of course, I didn't believe it, but it started making some sense. The proofs of the globe started sort of crumbling. The things that we think of that are really great proofs of the Earth being a spinning globe are actually just sort of misunderstandings that in a lot of cases can be interpreted a number of ways. For example, the mass of ships as observed by Columbus appearing over the horizon prior to the whole of the ship. They assumed that was because we live on a ball, but that actually is in line with the laws of perspective. So it's just all of these different things coming together. A person has to make that decision to go through the proofs and actually, sort of suspend your permanent belief of a spinning globe in order to get it. Because my initial reaction, again, when my friend asked me about it, was, what are you talking about? That's the stupidest thing. Who would even believe that? That's what we're programmed. And so ultimately, I became a card-carrying flat earther, never going back to a globe earther over the course of about a week.
Was there a particular one eureka moment, or was it just a gentle, gradual realization of the truth?
Well, the one thing that did it for me was when I was about 10 years old, I took my first airline flight, which was from Orlando, Florida to Dallas, Fort Worth, which is east to west, pretty straight east to west. And I just remember then as a 10-year-old, I couldn't understand how the two flights were identical in duration, because you would expect if the Earth was spinning, 800 or 900 miles an hour east at that latitude, the westbound flight should be a lot shorter than the eastbound flight, just simply because of relative speed between the plane and the destination. But of course, the two flights are identical. And so when I sort of realized this, I asked everybody I knew about it, and my parents, my aunt, and they just told me, it's because the planes are spinning prior to takeoff at the same rate as the ground, or the atmosphere is spinning with the ground. But all those arguments aside, it really never answered the question. But it was when I finally realized that and actually considered that the Earth might actually be stationary. That's the only way that actually makes sense. That's sort of what did it for me. But you know, everybody's different. Everybody has one thing that they like to hang on to, whether it's, you know, gravity for some reason is a big one for a lot of people, which is, to me, was not easy, or was not hard to sort of get past the whole idea of gravity on a spinning ball.
Well, that kind of was going to be my next question, which is, why do you think people in general think we live on a globe?
Well, it's indoctrination. We're told that is what it is from the time that we're very young. And from what I can tell, it's been that way for at least 100 years, maybe closer to 500 years. I really don't, it's hard to say, because, you know, history, you know, we really think we have history figured out right down to a point by point basis, but history is sort of a fickle thing, and there's lots of different, hard to say, ways of looking at things. But ultimately, you know, for sure, in the last 100 or 200 years, they've been teaching heliocentrism to all children for a very young age. And so to me, that's why most people think that the Earth is a spinning globe, is because that's what everyone's been taught since they were very young. And we're actually taught to think that if you think the Earth is anything but a spinning globe, then you are somehow stupid, or you don't understand physics, or whatever. But, you know, the plain fact of the matter is the Earth is a stationary plane, and that's what ultimately caused me to become a flat earther. Is it's demonstrably not spinning, and it's not a globe.
So, what's gravity?
Okay, well, I've got some theories on that. You know, gravity in the heliocentric model is the mass of the Earth warping space-time, and this sort of matrix of space-time is essentially, you know, it creates this sort of surface tension and nothing. So think of like pushing a beach ball underwater. That beach ball is going to displace a certain amount of water. Well, the mass of the Earth essentially displaces a certain amount of space-time, and that space-time sort of pushes back in on the globe in all directions. That's what, you know, the conventional, typical explanation of gravity is. In the flat Earth model, I think that it's something very much, just very simply, density and buoyancy, which are provable laws. And the ultimate tendency for down to be down has to do with probably the Earth sort of vibrating at a harmonic frequency that is similar to higher density objects. So a higher density object is compelled to the ground, while the air near the ground is shoved aside, you know, by the higher density object to allow for that connection to happen. So instead of thinking
Tesla that talked about frequency and vibration, and
yeah, definitely Tesla believed the world, or the universe, was a electromagnetic universe, and I think that's very true. And based from what I understand it, Tesla believed that the Earth was sort of like a big Tesla coil or a capacitor plate, and the ionosphere, or the ether, or whatever you want to call it, was you know, the other plate needed to make that connection. And so yeah, you know, Tesla had some inventions that we're still using to this day, but are guised in the cloak of what are ostensibly satellite technologies. But I firmly believe that you know, we are using Tesla-based, ground-based technologies in order to achieve, you know, ends in terms of GPS, or the internet and global communications. All that stuff's possible without satellites, and with technology that's been around since the 1940s or earlier.
So if it's flat, how flat is flat?
That's a good question. You know, one piece of trivia that I picked up from globe earthism is that pound for pound, the globe, if you're thinking about the globe model, the globe is more flat, or more perfectly spherical, than a billiards ball. So if you were to look at a billiards ball under an electron microscope, it would have, you know, more on average, it would have higher mountains and lower crevices than the Earth, and that's how perfectly spherical it is. So if you convert that to a flat Earth model, then I would say it's pretty darn flat. That's due to, you know, most of the Earth being water. But I also believe, and this, there's some pretty good evidence to support this, that the center, okay, and if we're thinking of it as a circular, sort of azimuthal, equidistant, flat Earth map with the North Pole in the center, the highest barometric pressure on average and by record is at the center, at the North Pole. And as you travel south, that barometric pressure gets less and less and less. So you get to the equator, and if you keep going south of the equator, the barometric pressure continues to decrease. And so what you would have is you'd have the oceans of the world responding to that barometric pressure. And so instead of being a perfectly tabletop flat, I could see it being somewhat concave, almost like a saucer or a dish, but certainly not concave in the respect that we're living on the inside of a ball like some others suggest, but nearly perfectly flat, but slightly concave is the way I would describe it.
Okay. I mean, the Coriolis effect is one of the sort of globe Earth proofs that gets bantered around, but to me has so many anomalies and contradictions in it. Can you talk us through a little bit of the Coriolis effect?
Sure, yeah. So the Coriolis effect is a fundamental law of objects that are rotating. So if you've got an object that's rotating, anything fixed to that object will be fixed to that rotational frame of reference. And what the Coriolis effect describes, the way that I like to put it is it describes how objects will behave when they're fixed to a rotational frame of reference and then released from that rotational frame of reference and compelled in a direction that's contrary to that constant spin around the axis. And so the Coriolis effect is it's a law of physics related to rotating bodies as a fixed frame of reference. And so when you look at things like the typhoons rotating one direction south of the equator and hurricanes rotating in the opposite direction north of the equator, then that's used to prove the globe. They'll say, see, the equator is spinning faster than everything else, and so the atmosphere, as it travels north of the equator, it's actually going to head left, I believe, or whatever it is. But at the end of the day, the Coriolis effect, if you apply the laws involved with the Coriolis effect, it disproves the Earth being a spinning globe, and that's where I sort of look at flight times. But not to sidestep the issue with the typhoons, but it seems like if you look at this in the flat Earth model, the sun is going around in circles concentric with the North Pole. During the northern summer, it's making its tightest path around the center across the Tropic of Cancer. And in the southern summer, it's going around the Tropic of Capricorn. And so over 6 months, it's sort of making wider circles and tighter circles, and that's what causes the seasons. But that path of the sun, it almost acts like an oar, or it's perturbing the atmosphere away from the center. And if you've ever been canoeing, you'll know that if you put an oar through water, you'll get opposite cyclonic rotation on either end of the perturbation. So to me, that explains the opposite rotating typhoons. But the Coriolis effect, so, if you take, for example, a westbound flight, from New York to LA, which is 2,500 miles, and compare that to it takes about 5 hours and 45 minutes, if I'm not mistaken. If you compare that to the return flight, they're often identical in duration. And so if you apply the laws involved with the Coriolis effect to those planes, it actually proves that the Earth is stationary. That's the only way that those two flights could have even a similar duration. If the plane taking off from New York is spinning east at, say, 850 miles an hour with the ground, when it lifts off and starts heading west, it's not going to remain fixed to that rotational frame of reference as the ground. It's just not. And nowhere in nature will you find objects fixed to a rotating body keep spinning around that rotating axis if they're not connected to the rotating body anymore. So at any rate, that the westbound plane is traveling towards LA, say at 500 miles an hour, or like accelerating in that direction. LA is going to start accelerating towards the plane at about the speed of sound or faster. And that westbound flight should arrive very quickly, just due to this principle of rotating bodies and how the plane should behave when it's compelled in a direction contrary to the spinning body.
So we have scientists like Neil deGrasse Tyson. I think he tweeted out something about a football or a field goal going in as a result of the Coriolis effect. Or the other one is snipers, where they say they factor in the Coriolis effect to long shots. It's sort of contradictory to the observable. How does that get squared in the Coriolis effect explanation from a heliocentric point of view?
It's totally ridiculous because if you ask any real good sniper that's that's not just a technical book smart sniper, but somebody that's actually an experienced sniper, they're not figuring in the Coriolis effect to make those long range shots. It just doesn't happen. And by the way, nor do artillery men, who would, you know, necessarily have to figure in the spin of the Earth. But when, you know, when people talk about
scale it up indefinitely.
Yeah. When people like Neil deGrasse talk about the Coriolis effect allowing for field goals, that's just wild speculation. That's just hyperbole. He's being a dummy. I'm sorry. When you actually look at, you know, what should occur, and you're talking about if you're at the equator, you're supposedly, you know, zipping east at 1,037.5 miles an hour. But it's not just that either. You're also dropping pretty darn fast. And I did some math, and you know, this may be pretty accurate. You know, I'm not going to swear by these numbers, but if you figure that if you're standing at the equator and you're traveling, say, 1,000 miles an hour eastward, well, if the Earth curves at 8 inches per mile squared, then you're going to be dropping at something like, I think it was like 666,000 feet per hour, just because of, you know, the curve of the Earth. You know, if you're traveling across a curve at that speed, you're going to drop at a calculable speed. And to me, you know, when a helicopter takes off, even if it was to maintain its eastward, you know, eastward momentum or its eastward angular velocity, it's not going to maintain that rotational frame of reference, which would be that dropping of 666,000 feet per hour. And so technically, you know, when a helicopter takes off, it should start to pretty quickly raise in altitude just by default, just by standing still. But, you know,
it led me quite nicely onto the next thing I was going to ask you about, which was gyroscopes and how they essentially prove or disprove flat Earth.
Sure. Yeah, I think gyroscopes are a good example of how the Earth is a plane. If you spin up a gyroscope, it's gonna it's just gonna naturally keep its same angular momentum. It's gonna want to sort of spin at that same angle that it's at when you spin it up. And so when you start traveling horizontally to the ground, a helicopter should start sort of phasing out of its upright angle, and they don't. It's going around a curve, and yet the gyro somehow knows that it's going around a curve when it shouldn't. That gyro should keep its same angle as if it was fixed to that plane before takeoff.
Right, it's reference to it.
Right. And so to me, yeah, I think, and you know, there's a lot of people that can talk about gyros a lot better than I can, but electrical engineer who's pretty famous in the UK, Eric Laithwaite, got fascinated with gyroscopes because they seem to have qualities that appear to defy the laws of gravity. If you spin up a heavy gyro and that's otherwise like you couldn't lift it up above certain degrees with your arm, when that thing spun up, you can spin it around your body with one arm like it's basically weightless. And if you know, if the Einsteinian theory of gravity were true, I just don't see how that could make a difference. You know, I don't see how spinning something could make a difference. But if, you know, the sort of the theory that I'm going with is, you know, the ground is resonating with a harmonic frequency that's similar to high density objects, and there's your attraction. To me, that sort of makes sense because it's, you know, the gyro is now out of phase with that harmonic resonance. I mean, it sort of makes sense to me. And
I mean, lots of people actually will tell you, regardless of how much proof you provide them with things like gyroscopes, that they can see a curve or have seen a curve, which is nonsense. But why do people assume they can see a curve?
Yeah, well, when I took, I've been on a few airline flights, but the first one I took was for some reason the most memorable because I was looking out the windows the whole time, and you know, after that, it sort of lost its luster. But yeah, I remember seeing a curve, my first flight. But what that is the horizon is always going to be an equidistant circle around you. So if you're, and that's depending on topography, of course, but let's say you're at the salt flats and there's just nothing around you for miles but just flatness. Well, the horizon is going to be at your eye level and in an equidistant circle around you. Well, if you gain an altitude, say at the top of a mountain, the horizon is still an equidistant circle all around you at eye level. And then if you look at weather balloon footage that's, you know, 20 or 30 miles high, the horizon is still an equidistant circle around that observer at eye level. And so that curvature, to me, as far as I can tell, comes from that horizon, actually the horizon line simply being an equidistant circle around you. And that's actually exacerbated if you're in an airline. A lot of them use convex glass, or like, sort of bubbled out glass for the windows, and it sort of adds to the illusion. But no, if you actually study high altitude flights, there is no sort of curvature of the horizon around a ball. And you look at Felix Baumgartner's 130,000-foot
Just what I
jump.
was about to come on to. It seems to be the globe in the Red Bull jump from space.
Right. Well, that's one tiny little ball, isn't it? But yeah, they're just using fisheye lenses, which I'd like to shoot whoever invented those, because who would want to see things from the perspective of a fish? But it makes basically all the straight lines appear to curve around a ball. And so that was I think it was pretty deceptive trick photography. But there are some telling shots from that Red Bull jump. For instance, there's one that's sort of shooting out from within the little capsule there, and you can see the horizons at eye level, right there in front of the little door, or whatever you want to call it, bulkhead, I guess they would call it. But yeah, there's the horizon right there at eye level. And then there's another shot looking down directly from overhead, and the Earth is totally stationary when it should be spinning towards the east. It really should, even if people argue that, well, he was spinning at the same speed as the ground before they zipped up, and therefore he continues spinning east with the ground for the entire duration, and that's why it looks like he's stationary. But it's ridiculous, because if the Earth is a spinning globe, then the higher up you go, you must be traveling across a greater arc. Okay, that arc is going to be a longer distance in space, and so you'd have to accelerate eastward, in direct proportion with your altitude. So the higher up you go, the faster east you'd need to go just to, apparently remain fixed above the ground. But it just doesn't happen. There's no curvature, and this darn thing isn't spinning. As ridiculous as it sounds, I know how crazy it sounds for people that are first time hearing this. I don't know, but we've all been trained our whole lives to assume that infinite space is true, and we live in the.
How have we been trained?
Well, God, I mean, it goes back to literally the crib in some cases. I talk to people where their babies' rooms are space-themed rooms with little solar system mobiles above the crib. So, I say that there's arguably a cross-section of the population that has their first memories sort of ingrained or tattooed with heliocentrism. So, yeah, it goes back pretty deep. But yeah, when you really do just look at this thing objectively, and you try to get rid of some of these assumptions, like, we all assume that the sun is this 93 million mile distant ball of atomic fusion. And in fact, the same numbers that are used to prove the sun is 93 million miles away and 110 times bigger than the Earth, using spherical trigonometry. But if you just use plane trigonometry, then you can prove the sun is less than 4,000 miles away and only about 35 or so miles in diameter. So, yeah, there is a logical alternative to heliocentrism, and to me, that was the big thing. Is I didn't even know there was a debate. I thought that it was just a foregone conclusion my entire life that the Earth is a spinning globe, and that's what it was. But I think simply raising the question and debating this thing as rational adults as opposed to toddlers, I think that's a good thing. I think it can only lead us closer to the truth, and that's why to me it's so important, because at the end of the day, it happens to be the truth. So
you've done some fairly detailed observations of the stars. Can you give us a little explanation of parallax and what maybe we should see?
Sure. Yeah. We should see, and people say that the distances to the stars are so vast that we wouldn't see any sort of parallax, but that may be true. But our angle of
sorry, can you just explain to anybody who may not understand what parallax actually is, what that in literal terms means?
Sure. Yeah. Okay. So let's just say if you've got something that's 3 feet away from you, a can of soda, and then you've got something that's 10 feet away from you, say a chair, and something that's 20 feet away from you, I don't know, a picture on the wall. If you move your head side to side, the can of soda in front of you is going to move quicker relative to your point of view, and things that are further in the distance are going to appear to move at a slower rate. And so all parallax is essentially the relationships between objects changing due to your perspective changing slightly. And since those objects are more and more and more distant, they're going to apparently, you know, slide across your line of sight at varying rates depending on distance.
I like to use the train example. If you're on a train and you've got a load of bushes going past you, the bushes look like they're going really fast, whereas the mountains in the background aren't.
Exactly.
Can you explain how your sort of star studies related back, and how you sort of showed that there is no parallax ever?
Well, and you know, the thing is okay, so if we're going around the sun and the sun's going around the galactic center, and the sheer distances of the stars aren't enough to cause any parallax, I think that's a baloney argument anyway, because the closest, you know, visible with the eye star is, I want to say 4 light years. I could be way off, but I want to say 4 light years and something like that, or 400, whatever.
Alpha Centauri, I think it is.
Okay, well, whatever. But the most distant star with your visible eye, with your naked eye, is 4,000 light years, and you've basically got everything in between. So, you know, just simply spinning around, you should see all sorts of parallax, but that isn't even, you know, my main argument. I think that the main argument that sort of totally crushes heliocentrism is the idea that we can see the same stars overhead during summer versus winter. And this really doesn't have anything to do with parallax. It has to do with visible space being the sector of the night sky that the Earth happens to be pointing to at night at a given time. So let me break that down, because I know it sounds more complex than it is. And again, we're sort of humoring the globe model here, so we're not thinking in flat Earth terms, we're thinking in heliocentric terms.
Sure, we're explaining what we should understand and see in reality if we live on a globe, which we don't, but that's how we're talking.
Exactly, that's right. So, okay, so if you can just picture during the winter, the Earth is on the left-hand side of the sun, and it's tilted. We'll say that it's winter in the south, so it's tilted towards the left. The south end of the globe is sort of facing in towards the sun. Well, that means that the sector of visible space is going to be the area of space way off to the left. You can't study the stars during the daytime, so when the Earth spins around towards the inside of this little circuit, it's daytime. You can't see the stars. And then when the Earth spins around towards, it's facing the opposite end of the universe. Now it's facing off to the left and sort of up. So now you've got your night sky in the winter. So fast forward 6 months, and the Earth is on the opposite side of the sun. Then during the daytime, everything that you could see at night in the winter should be completely invisible. It's daytime. You can't see anything. But what we actually see in reality here on the ground and on the flat Earth is we see many of the same stars and constellations in the summer, also in the winter. And this is just simply impossible. This has nothing to do really with parallax. It has to do with which direction are you facing in space. The stars overhead during summer should be on the complete opposite end of the entire universe during the other 6 months period, summer versus winter. And the same thing goes with autumn and spring. You should never see the same sets of constellations from season to season. There might be a few that overlap a little bit, but certainly not summer to winter. There's just no way. It's impossible. And that's one big proof. Now the other thing too is the North Star Polaris remains fixed above.
To bring you onto the North Star.
Yeah, it just stays fixed above the North Pole, and it does go around a little bit. But if we're spinning around on an axis that's tilted in towards the sun during the winter and tilted away from the sun in the summer, or however you want to look at it, there's just no possible way that you could see Polaris at night, every night, right above the North Pole, and then to top all that off year after year after year. Because you got to remember, we're not just going around the sun. The sun's supposedly traveling at 500,000 miles an hour around a curve. So our little, January 1st of one year would be a completely different place in space than January 1st of the next year. And not just different place, it would be a different angle. you know, people say stellar parallax isn't going to occur because they're so distant, but in order for those distant alignments to stay aligned, you have to have perfect alignment. And if you're off by even just a single degree here on the ground, if we're talking about stars that are, you know, trillions of miles away, then they're going to be way out of alignment just out of a fraction of a degree of difference here on the ground. So it's, you know, there is no stellar parallax. There is no possible way we could see these stars from summer to winter, yet we do. There is no spinning. You know, the east to west flight times prove that fairly well. There's no curvature. The horizon raises with eye level regardless of altitude, and the thing's not spinning. So, you know, at the end of the day, we're left with, you know, this heliocentrism looking really, really bad in terms of an explanation of reality. And when you look at how did we arrive at these conclusions, most of this stuff is just, you know, it's almost ancient history. The Cavendish experiments, where we derived the so-called gravitational constant, was in 1731. Newton, who, you know, sort of came up with the theory of gravity, was long before then. We still use the Mercator projection, which was from the 1500s. That's how we base our modern maps, is from that Mercator projection still. So it's just, you know, it's almost like this thing needs another look at it, because the world that came up with heliocentrism totally didn't understand electromagnetism at all. They didn't have the modern luxuries and technologies we do, like instant communication or airplanes, or even, you know, in the case of Newton, they didn't even have hot air balloons. And there's just there's so many different things that we can do to prove this, but the problem is, you know,
I mean, we've sort of had fed to us the idea of the globe from people who had absolutely no way of verifying it, but knew exactly what it was, exactly how big it was, exactly how much it weighed. It's total nonsense.
Oh yeah, yeah. Well, like the Mercator projection.
I was going to say, we've established that we don't spin. There's no curve. We're essentially living on flat Earth. How has this affected your day-to-day life, John?
Well, to me, it's been very liberating. You know, it's hard to describe, but, you know, I think that there's a lot of psychological stigmas, or sort of like a lot of psychological baggage that comes along with heliocentrism. It sort of separates us from anything unique. We're just another little spinning ball, just like the ones we can see in the night sky.
Right.
We're just another planet.
The heliocentric model.
Right, that's right. And so, and it's also very dangerous. You know, I've always sort of wondered, well, how do we know we're not heading straight for a black hole, that we could run into a black hole any day? But,
yeah,
you know,
it's pretty terrifying as well.
Yeah, there's all sorts of things that can go wrong when you're zipping around the cosmos at a gazillion miles an hour. But when you realize for a fact that the ground that you're standing on hasn't moved even a single yard ever, it's sort of a comforting fact to know. And, you know, it also puts us in the perspective of, you know, not just like this accident of life that sort of happened because of the right conditions on this chemical planet, but, you know, there actually is something special to us, and there is something special about this world. And, you know, to me, it's been very liberating, and it's sort of been, you know, I've experienced positive health effects. I sleep a lot better at night. I used to have pretty bad heart palpitations, and those have just sort of pretty much quit ever since I've really firmly understood this to be true. And so, yeah, I think
it's quite open with your friends and family about your position on flat Earth.
Well, I mean, my friends, you know, they know what I'm doing. I post everything up on Facebook. You know, my mom, I haven't really talked to her about it much, but you know, I post up all the links to my videos and stuff, so she knows what I'm doing. I think she's supportive of it, but you know, at the end of the day, I'm doing this simply because I just feel like I have a moral obligation to. The first video I made was on May 1st of 2015, and you know, it really is sticking your neck out there. You think, you know, you worry about how people are going to think of you. People are going to think I'm stupid. People are going to think I'm crazy. But you know, the thing is if you actually take the time to think this through and go through the experimentation and go through the proofs, the person in this conversation with major delusions is the one that they believe is the one that believes they live stuck to the side of a spinning ball.
Once you find out, and this is probably true for a lot of people, once they find out, you kind of it's almost impossible to kind of wrap your head around the heliocentric model and believe it. You can understand it, but you can't go back to believing that there's people upside down from you dropping their pen up towards your feet. It's just complete and utter nonsense.
Totally. Well, and another thing that because flatness is a big part of this, but to me, I guess the bigger part of this to me was the motion or the lack of motion. Because if you think about it this way, even in a single day, think of the different inertial effects you should experience on the spinning globe. So let's just say during this certain time of year that when the sun is rising, the Earth is racing up towards your feet at 600 miles an hour. So that's 66,600 miles an hour. It's racing up at your feet. Well, that's that same day, but 12 hours later, you would have gone through a phase all the way to now the Earth is racing down away from your feet at 600 miles an hour. And, you should feel like all these weird changes in apparent motion. And then if you were to travel north, just like several degrees in latitude, you'd be spinning, a lot less than you're used to. It's just, we don't see any of this in reality. We don't experience any of this. To me, it's.
Do we? I mean, you co-host the Globebusters show looking at the ISS. I mean, does the ISS hold a proof for the globe? Because it does for a lot of mere mortals that still live on a globe.
Right. Well, I think it's, it's just like a good magician has misdirection. And so if you show somebody high altitude flights with, a little bit of trickery, then there you go. There's a globe. But to me, I think that what we're seeing when we're watching the ISS feed is definitely some trickery. I think it's a combination of high altitude flight, which, by the way, high altitude flight looks very similar to low Earth orbit. I think the only difference is they use fisheye lenses and trick photography. But yeah, I think what we're looking for the regular ISS feed is just, layers of, CGI. You've got some real footage, you've got some CGI, and you've probably got some models in there. And at the end of the day, with a budget of $20 billion, frankly, I think they should do a lot better. But it's almost like they have to make it look, rusty and grainy in order to give it that sort of, character, I guess you could say.
I mean, if we assume that space isn't as they tell us, this, for most normal people, will raise more questions than it answers. What's the biggest question for you?
In terms of space?
Well, in terms of the void that's left, because with the heliocentric model, we've got pretty much everything covered and we've got answers for almost everything. Why is the sky blue? You look at the heliocentric model, there's an explanation. As soon as you find out space isn't real, if you want to look at it in that way, it leaves loads and loads of unanswered questions. Was there a particular big question that you had now that you're on the flat plane that you would really love to have answered?
Well, and this will probably not answer the question, but in the heliocentric model, we're supposed to believe that everything came from an explosion, that the entire, everything in the universe was compressed down into the size of either a golf ball or a pinhead or possibly the size of an atom or smaller, but everything was just compressed and then exploded, and now we live on a little chunk of this explosion that's spinning around in space. So that's what we're expected to believe in the heliocentric model, whereas here in the flat earth model, what we understand as space is really just a feature of our world. And so, astronomers looking at the night sky and trying to weigh galaxies and trying to figure out, if there's life on any of these little lights in the sky or whatever, I think it's a waste of time. I think that if there is any infinitude to this thing, it would probably be, or possibly is, laterally, so parallel to the ground. So I don't see any
I don't
problem.
understand what you mean. Sorry.
Well, if you think in the heliocentric terms, if you look up in the sky, it's an infinity of space. But what I'm saying is that space is, the stars up there are just probably a few thousand miles away, and you're not going to go much further than that. But if you were to go, say, south, and basically south is every direction away from the North Pole. So if you were to go away from the center in any direction, this plane, the physical plane, could extend well beyond the boundaries of the path of the sun. So we could live on an infinite plane. There could be other worlds nestled in this, physical plane very nearby. I'm not saying that is what it is. I'm theorizing, but there's a
Sure.
lot of high profile flat earthers out there that are pushing an enclosed system. They're saying it's definitely, an enclosed system. There's definitely a glass dome in the sky or whatever. But I don't, the model that I subscribe to, there is no sort of dome and there is no sort of edge. I think that we could probably, and, I stand to be corrected on this, but I think that we could probably go south in any direction and find another similar world with its own little solar system or its own little universe, if you want to call it that. But that would be the one question that I would want answered. And by the way, one of the things I've done recently is set up a petition to abolish the Arctic and Antarctic treaties. So maybe I can shoot you over a link to that. But
I signed it.
did you? Awesome. Well, thank you. Yeah, we've got a few hundred people signed it so far, almost 300, I think, the last time I checked. I want to get 100,000 because that'll answer a lot of questions. That'll put a lot of this stuff to rest. Because as it stands now,
I mean, I'm jumping along a little bit, but that was one of my questions, which is why do you want to abolish the Arctic and Antarctic treaties?
Well, one thing that was sort of pointed out to me and affirmed to me by Matt Boylan when we spoke, actually just this past Sunday, I spoke with him for the first time on the show with Laurie Ferrari and Lawrence Wright on This Week in Flat Earth. But these corporations, or these militaries have been violating their own treaty. There's not supposed to be any military activity in the Antarctic regions, and there actually absolutely is. And so, first of all, they're violating their own treaty. But second of all, think of in the last 50 years or even less, think of all of the energy crises that we've had. And we've got this huge addiction to foreign oil, which happens to be, fueling our so-called apparent enemies over in the Muslim lands, when this entire time, these corporations, and instead of ruining the ecosystems right off the coastal waters or, drilling in our backyard or fracking in, the plains or strip mine in the mountains, they could be off in Antarctica doing this to where there's plentiful resources. So that's one of the reasons why, I'd like to see it abolished, is so that we could, we could see what sort of potential there is for future generations. But I suspect that there's probably a lot of government and corporate activity going on there anyway. And so, I just don't see them leaving that huge. And whether we're talking about a continent on the bottom of a sphere or whether we're talking about an area that's basically potentially enveloping the entire known world, potentially, then there's a huge amount of land, there's a huge amount of potential, there's lots and lots of resources that are just sitting there, doing nothing after, all these decades of energy crises. I don't know. I just don't see the governments and corporations being so naive. And I see the governments protecting those areas, which they do. And I see the corporations and the government sort of being in bed together anyways. So why not? So I think it's something that needs to be revisited.
Vast resources down there. And
yeah.
I already know the answer to this, but where's your reference for there being vast resources down in either the circle that surrounds us or the continent that's on the bottom of the globe?
Sure. Well, and you can take this at face value or with a grain of salt, but back in the 50s, U.S. Admiral Richard Byrd went down to the Antarctic for Operation High Jump. And they did, just a bunch of surveying and just basically checking out the place and seeing what was down there. And they found all sorts of stuff: coal, potentially oil, plutonium. It's basically an untapped entire landmass. He referred to it as there was a landmass larger than all of the Americas south of the pole, which is a little bit baffling if you think about that in globe Earth terms. So, yeah, that's one reference. But if you just think about it logically, I mean, the Earth is it's rich in natural resources. And if you look underneath the ice, according to Byrd and according to other people that have gone out there, it actually apparently used to be tropical. There's still sort of warm water I guess you could say warm water ecosystems that pop in and out down there. So there's potential down there. And I just think that it's, whether we live on a globe or whether we live on a plane, and that is sort of an artificial boundary, that we as free people are, we should be able to make these decisions. I think that the Antarctic Treaty, that since it was signed in the 1950s, by who? I mean, the people who signed it aren't even around anymore, and it's not even up for debate for another 25 years. I think that we should revisit it, and I think that if enough people, get behind it, and you don't even have to be a flat earther, you don't even have to mention it. The language of the petition doesn't even mention the notion or the word flat earth in it at all. This is for everybody. This isn't just for one country or one type of person. This Antarctic Treaty, to me, is a huge piece of the framework that's essentially keeping us in the status quo. And
yeah, just to clarify, because I'll put a link to this in the description of this video when it goes for archive. But yeah, the petition that you've put together, it is very cleverly phrased in the respect that it has nothing to do with flat Earth. Obviously, it has everything to do with flat Earth, but you can happily send it to your friends and work colleagues, and fear not, they will not think you're bonkers flat earther for sending them this. It's a perfectly reasonable proposition to abolish what is currently, I am right in saying it's the longest standing treaty in history.
Right. Yeah, it totally is. And to me, it's just impressive. We should be able to do, we should be able to go and do what we want. Nobody owns the Antarctic. Nobody owns those waters, but the world has set up a treaty to where you can't bring or store excess fuel down there. So even if you could make it, what are you going to do? You're going to turn around and probably die trying, because and from what I've seen, they will actually stop you. People argue, oh, you can go down to the Antarctic, you can take guided tours. They send middle school field trips down there. That may be the case, but they take you to it's a guided tour. They take you to where they want you to see, and that's it. You're not, there is no free roaming. And to me, I think that it would become pretty apparent pretty quickly that something's going on here if we were actually able to really, flesh out the southernmost regions, which, even back in the 1800s, they were trying to do. They were trying to circumnavigate the southernmost regions, and they never could. They could never make their way all the way around of it. So, and I think we were talking about this before the show. The path of the sun is definitely circular, but I think it may be a leap of logic, or maybe it may a bit naive to ascribe the circular path of the sun to necessarily describe the face of our world in terms of mapping. And so I'm under the impression that we really don't have any accurate maps in terms of.
I'd agree with you. I mean, I think everything we've been handed down has been given us by the elites. And my last guest, Martin, was explaining that while he was out at sea, he would have constant updates, and he speculated where they come from as being the USGS. But he was saying that the seaways would be changing all the time. The lanes that they had to abide by were changing all the time. And the maps that they were using were changing all the time. And the end result is we have dozens and dozens and dozens of projections and maps that we can cross-reference and find that none of them tie up to each other at all.
Well, and that's right. And the thing about a map is it's just used to aid somebody in navigation. And so, like, the Mercator projection is a cylindrical conformal map. That's still sort of what we use today to visualize the Earth. But what that means is a cylindrical conformal map is it's nearest to correct at the equator. But the further north or south you get away from the equator, the more and more the relative sizes and distances get skewed. And so up until the point till you get to the poles, where it's so skewed that the single line across the top and bottom of the map is basically stretched out to infinity. And so you've got this huge, I mean, I just don't even understand how you could call that accurate. But the reason that they designed it that way is so that navigators can maintain lines of constant course. And so as long as they know how to navigate, they can use those maps to get from point A to point B. But
yeah, they're still out of reckoning quite often.
What's that?
They're still out of reckoning. In other words, they'll still be late or early or
Sure.
off course.
Sure, and especially in the southern hemispheres, because I think, it seems to me, and I really do tend to agree with the sort of the standard Robotham model. There are some issues with it, like, for example, the flight from Sydney, Australia to Santiago, Chile in 13 hours, if that's allegedly true. To me, that doesn't disprove the flat Earth. It just means it affirms to me that we don't have any accurate maps.
I'm sure Tiger Dan said in his most recent, I think it was part 5 of his cartography video, was saying that he had, I may be wrong about this, but I'm sure he said he'd actually taken that flight in his 20s, and that there was a blog that showed a stop off point, and that was kind of people's flat Earth debunking and saying, well, there is no direct flight. Whereas Tiger Dan said, no, I think I've done that flight. I hope I'm not wrong in saying that. But yeah, he's having lots of problems. Well, I won't take your words out of your mouth, because it was you that had brought this up before we started recording. Do you want to just talk us a little bit through your impressions?
Sure. Yeah, and I've been watching Tiger Dan's. Where what he's doing is he's taking the known distances between certain airports and mapping those out on the flat Earth map. But and I do like the idea. I think it's a good idea. But the issue that I have with it is he's still mapping it out on an azimuthal equidistant matrix, and that's where I sort of have an issue with it, because we're just already assuming that this thing is a circular disk with the North Pole in the center, and the the imaginary latitude and longitude lines are what they say they are, or are what we think they are. And I think that's sort of a problem. Again, my sort of issue with this is we're looking at the sun and saying, okay, it's daytime here now, at noon. And then 12 hours later, it's noon on the other side. Therefore, it's a circle and all these. But I just think that we're making too many assumptions on that part, because the sun, to me, is still sort of a big mystery, or at least our ability to accurately or unbiasedly observe the sun, it isn't there.
Well, do you think it's possible at all to map out where we live?
I think it is totally possible. But I just think that we're missing something, and whether
that would imply that people have done this and do know exactly where we live. Why would we have the globe lie if that was the case? What's the purpose?
Well, I think the purpose is to keep us here. I think the whole motive of the whole thing is to keep us here, basically like cattle. They don't want us straying too far away from the edges, to the edges. They don't want us escaping and possibly finding other worlds, or on the other hand, finding a dome and finding evidence of our, the fingerprint signature of the creator on it, however you want to look at it. That's what I see as the motive. But just getting back to the map, for example, like, let's just say that the North Pole isn't a single point at the center of the azimuthal equidistant map. What if what we think of as the North Pole is wrapped around a larger area? Then you're going to get a totally different map with different relative distances. And so it's that's sort of what I'm talking about. And until we're able to really map out the center, really map out the North Pole, and really map out the southernmost region as free sovereign people with technology, then a lot of these questions are just going to remain unanswered, and we're going to have to use the assumptions that this azimuthal equidistant projection is correct. And so that's why, I love Tiger Dan. He's done a lot of great work, and I think it's a good idea what he's doing in terms of mapping out distances relative to known, airports. But at the same time, he's applying those distances to a matrix that we've already sort of, I guess has already sort of been debunked. And again,
a lot of the work you do is debunking heliocentrism. That's not the right word? The heliocentric model.
Sure.
Have you made any proof towards answers or evidence towards flat Earth?
Sure. Well, yeah. The big things are no spinning, no curvature. It's not always what you see is what you get. You've got things like refraction in terms of light. So when the light that we see from the sun is passing through layers of apparently magnetic fusion ion tubes or whatever they are up there in the lower magnetosphere, and then you've got different layers of magnetic fields and atmosphere. And so what we see as the sun might not necessarily be the sun. And so, it's just, I'd rather say, this is sort of a mystery to me than to say, well, the sun is definitely, 4,000 miles that way, because what we see as the sun, that might not actually be the source. Or I guess the matrix of reality, since we're sort of stuck in this electromagnetic bubble, as it were, anything that's beyond that matrix of reality is sort of beyond our capacity to really, truly, fully understand. And so hopefully that answers the question. Probably not.
Well, no, definitely. I mean, the question that I touched on before we went out, and again, it was something we were both a bit vague about, was Shell's withdrawal due to poor return on investment. I think it was 8 billion that they pumped into being just north of Alaska. What were your sort of impressions? Sort of, I think it was back in September that they actually withdrew, September 15. What were your feelings about that?
Well, yeah, and you had mentioned that before the show. And now, does this have to do with that whole the pipeline, the Keystone pipeline, or am I wrong?
I don't know. I mean, it was information that was given to me by my dad, and as I started looking into it, I found a Facebook site that was saying that they wanted them to withdraw from Antarctica, and I thought, no, well, either someone's just made a mistake on how they've publicised their trying to get Shell out of this region. But it was, I put it to my dad that someone had made a mistake, but on the other hand, it could be deliberate disinformation to make it seem like they were, intentionally mining Antarctica, despite it actually being the Arctic region. I mean, I don't know.
Well, yeah, and it could have been a typo, so it could have been something simple.
Exactly.
Or it could be, I'm totally under the impression that I wouldn't be surprised at all if the big oil companies, were in the Antarctic doing their thing, even though it is against the Arctic and Antarctic treaties for them to do that. Just think of, no competition, nobody, no tree huggers getting in their way. There's no animal, there's no natural indigenous types of animals that live in the Antarctic. So it is the perfect place for that sort of corporate activity. So perhaps it was a typo, perhaps it was misinformation, or perhaps they accidentally let something slip. But yeah, I mean, I think that if we're going to drill for oil, we should probably do it in places that are far enough away from civilization. But I've come to the conclusion we don't even need, quote unquote, fossil fuels, which are not made out of fossils, by the way. But we really don't even need those fossil fuels anymore. We have the technologies, we have the ability to totally go off of that sort of power, but we don't, because it makes, just a select few people too damn rich. And they're going to do whatever they can to monetize the crap out of everything they can, and we pay through the teeth for it. But yeah,
definitely. I mean, I've pretty much covered everything I wanted to go through with you. Was there anything that you wanted to sort of promote before we end the show?
Sure. Yeah, I just released a new video. It's What Goes Up Must Come Down, and just sort of theorizing on a different way of looking at gravity. That's something that for some reason people tend to think of gravity as proof of a spinning globe. So, what goes up must come down, therefore we live on a spinning globe. It's incomplete logic. Newton was an excellent mathematician, obviously, who described how this may be possible. But when you actually apply the numbers, when you apply the physics to, a stationary plane versus the spinning globe, the numbers and the physics and really reality works a whole lot better in the stationary plane model, because a stationary plane it is. So, that's just something that I always like to sort of say is this is the simple truth. This isn't some bizarre conspiracy theory. And, if you try to bring this topic up to most people, they're going to look at you like you just, like your head just popped off. But in reality, if you can give the person a chance, our initial first reaction is always going to be to snub this and think it's the stupidest thing ever, because that's what we're trained. But if you care about a person and you really want them to know the truth, just give them time. Give them time. We've all been there. And if a person really wants to dig through this and dig through the rabbit hole and look at the proofs and look at the evidence and think about, your experience as an observer for your entire life, think of which one makes more sense and come to your own conclusions. But yeah, at least we know there's a debate. So welcome to the debate, at least, if this helps you get there.
But just to round up then, what's your conclusion, John? The Morgile?
My conclusion?
Yeah. Where did it live?
Oh, well, it's definitely not a spinning globe. It's a stationary plane, and it's probably got a bit of concavity to it. So, you know, again, the barometric pressure is the highest at the center, which is the North Pole's at the center. And as you go south in any direction away from the center, the barometric pressure gets lower and lower. Even as you go beyond the equator, the barometric pressure continues to get lower. And so if the water of the seas reacts to that sort of thing, then you've got a concavity. We're, you know, certainly not wrapped around the inside of a ball, just maybe a slight concavity, but certainly almost perfectly flat.
That's it. We definitely do not live on a globe. Now you're on, is it the ISS watch tonight on Globebusters?
Yep, we'll be doing 8 p.m. Eastern time, so that's here in about 3 hours. So definitely come in and hang out with us. We've missed a couple of weeks. We've had a schedule change. So yeah, we do that Wednesdays at 8, Sundays at 3 Eastern Standard Time. And then I'm also on Sundays at 6 with Lori Frary and Lawrence Wright on This Week in Flat Earth. So check that out too. That's on Flat Earth Conspiracy on YouTube. And yeah, check out the channel, The Morgile. Lots of good videos there, and lots of proofs, lots of evidence, and hopefully we'll get this Antarctic thing signed to 100,000 by the end of 2016.
Hopefully so. John, also known as The Morgile, it has been an absolute pleasure having you on Flat Earth UK Live.
Awesome. Thanks so much for having me, Nathan. It's been a real pleasure.
Yeah, the pleasure was definitely all mine. Thanks again. To all of you who have been chatting, thank you very much for tuning in. I've been Nathan Oakley, and I will see you all in the next video.